Hello and welcome to this episode of the Geotechnical Engineering Podcast. In this episode, I'll be talking with Jeffrey Rissman, Senior Director of the Industry Program at Energy Innovation Policy and Technology, LLC. We'll be talking about the crucial role of advanced technologies in industry decarbonization. We'll be talking about the balance between climate action and industrial transformation. We will also be talking about the journey towards a zero carbon industrial economy. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, there's a quick word from our sponsor for today's episode, that being PPI Kaplan Company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
All right, Jeffrey, how are you doing? Welcome to the show.
Hi, Jared. I'm doing really well. Thank you so much for having me on.
Great. I've been really looking forward to this conversation. So glad that you could be here with us. And to set the stage, would be helpful for us if you could tell the listeners and those that are watching a little bit more about yourself, talk about your career journey, and how is it that you were led to focus on the industrial sector's role in climate change? Like, there's a lot to unpack there. Take us on that journey, please.
Yeah. So I'm the Senior Director of the Industry Program at Energy Innovation. Energy Innovation is a nonpartisan clean energy climate policy think tank. We look at the technologies and policies that can cut emissions. And as the head of the industry program, I'm focused on the manufacturing sector. So the making of steel and cement and chemicals, the things that go into buildings and infrastructure and all the products we use every day. So my career journey, well, I've been with Energy Innovation since the company started in 2012. Before that, I was in graduate school, actually, where I got a degree in environmental engineering, as well as one in city planning. I thought I was wanting to work on something that would blend science and technical knowledge with a public policy goal that would really help improve people's lives. And I thought maybe I could be a green city planner. But I ended up getting this job, helping to start this think tank, and focused for a while on computer modeling of technologies and emissions. I developed a tool called the Energy Policy Simulator, an open source computer model, and we adapted it to multiple countries and regions. And I kept seeing that the industrial sector was this huge portion of the emissions, and it was not being adequately addressed by public policy. The technology levers weren't as developed as in other sectors like transport or electric power. And so I proposed starting this industrial program and leading it. And that led me to my current role and to creating the book, Zero Carbon Industry, which just came out from Columbia University Press.
Excellent. Well, thank you so much. Can you share a little bit of some of the advanced technologies for industry decarbonization that you cover in the book?
Sure. So the book is divided into three big sections. The first section is on the top emitting industries, which are iron and steel making, cement and concrete, and chemicals, which includes plastics and so on. And those sections include discussion of technologies specific to those industries, allowing you to produce, for example, zero carbon primary steel from iron ore. Maybe I'll return to that in a moment as an example of a technology. The second section is cross-cutting technologies, things like energy efficiency, material efficiency, direct electrification of industrial heat, hydrogen and other renewable fuels, and carbon capture. And then the last section is on policies to help these technologies be commercialized, deployed, and scaled up. There are just so many amazing technologies coming here and coming down the pipe for clean industry. So it's hard to pick just one, but I can mention some from the steel sector because it's so relevant to construction and engineering because it's a part of buildings and bridges and infrastructure. So steel can be made either primary steel, which is from iron ore, or secondary steel, which is recycled from scrap steel. It's relatively efficient and environmentally friendly to make secondary steel, but we can't use it to satisfy our entire steel demand because there isn't enough scrap to recycle to provide for all the steel demand. So we need a way to create zero-carbon primary steel. And there's sort of three leading technologies that can do that. One is called hydrogen direct reduced iron. So this is chemical reduction. Essentially, iron ore is iron oxides, iron bound to oxygen. And you need to chemically remove that oxygen to leave behind metallic iron, which is the main ingredient in steel. So traditionally, that's done in a blast furnace, this large, a multi-story tall machine that burns coal and coke, a carbon-based, coal-based fuel, to create carbon monoxide and hydrogen mixture that then chemically reduces the iron ore. But it can be done with pure hydrogen, which can be created cleanly from hydrogen electrolysis in a process called direct reduced iron, a different kind of furnace. And then you would move it to an electric arc furnace to melt it and convert it into steel. The other approaches involve electrolysis. So instead of using a chemical to remove the oxygen, you just apply electricity directly to split iron ore into metallic iron and oxygen. That can be done either in an aqueous solution where you grind up the iron ore and put it into an alkaline or acidic solution. You insert electrodes and apply a current between them, and iron particles deposit on one of the electrodes. Or you can do it what's called molten oxide electrolysis, which is done at very high temperature in an electrochemical cell. And molten iron pools on the bottom, and the impurities are separated and pool on the top, a material called slag. All of these technologies are being investigated, and direct reduced iron is already in use, for example, in a project called Hybrid in Sweden. And the U.S. government is now funding a couple demonstration projects related to clean steel as well.
Interesting. Thank you so much. So your book, Zero Carbon Industry, Transformative Technologies and Policies to Achieve Sustainable Prosperity. How does this book address the complexity of manufacturing regulations while ensuring that firms remain competitive? And you touched on this a little bit, like some of the processes, but what are your thoughts there, Jeffrey?
So policy is key to a transition to clean energy. Regulation, policy, financial incentives. And I think the one key thing to note is that there isn't a single silver bullet policy. There's not one type of regulation that will work for all industries and all technologies. So the book walks through a number of approaches that are best suited to different levels of technological maturity. So, for example, when a technology is still at laboratory scale, or maybe it has a demonstration project and they're trying to do the first commercial scale example, financial incentives are a powerful policy here. It's not too expensive for government because there's only a few of these, or one of these projects going on for a given company or given technology. And it gives that technology a chance to deploy and scale up and work out some of the engineering details. Another great policy at the early stage would be green public procurement. So governments purchase a lot of these materials. They purchase a lot of cement and concrete and steel because it goes into roads and bridges and public buildings. So government can set aside, let's just say 5% of their steel budget and say, this is going to be devoted to purchasing zero carbon primary steel. And that gives steelmaking companies the confidence they need to invest in producing a production line for zero carbon primary steel. They know they're going to have a buyer. And then as the scale grows and the costs come down, the government can ration it up. Then they'll buy 10% and then 20% of their steel from this process. And then the steelmaker will start selling to the private market, maybe car makers who want to make their cars out of clean steel. There are other technologies for other parts of the process. Policies, other policies for other parts of the process, other technological maturity levels. Carbon pricing, for example, is a regulation that works best later in technological maturity, once there's a commercialized clean option that industries can pivot to at an affordable price. So the book really tries to stitch it all together and show how these policies can work together to accelerate this transition.
Thank you for that. And what ways do you see countries striking a balance between pressing the need for climate action and the practicalities of institutional transformation?
So climate action is urgent because greenhouse gas emissions are already causing climate damages and need to come down in order for countries to meet their existing pledges and in order to stabilize the climate. Ultimately, the industry sector is responsible for a third of global human-caused greenhouse gas emissions, including emissions from electricity purchased by industry. Excluding that, it's about a quarter of greenhouse gas emissions. Either way, it's a huge share, and there's no way to stop global warming unless industry transitions to clean production practices. So countries, fortunately, are recognizing this, and there's new and exciting developments on the policy front with regard to encouraging a transition to clean industry and making this rewarding for manufacturers. I would say Europe is probably the region that has led in this with a lot of its targets, and so many European firms have announced zero carbon targets, often in the 2045, 2050 range. And many of the projects, like the clean steel ones I mentioned earlier, were in Europe. But now the United States is also investing in this area with new funding from the Inflation Reduction Act and other policies like the Bipartisan Infrastructure Law and various offices within the Department of Energy that provide technical and financial support to manufacturers. So I think it's an exciting time, and policymakers are beginning to recognize that this is a crucial area to focus on now in order to achieve our political and environmental goals.
Excellent. In your vision, what does the intersection of job creation and a zero carbon industrial economy look like in your vision, Jeffrey?
So I think these things are intertwined. So to get to zero carbon industry, there needs to be investment in new technologies, in new production processes, in workers. So, and of all the things that government can spend its money on, investing in productive new capital equipment, new factories and technologies, and investing in workers is one of the things that will bring the greatest economic returns in terms of job growth and technological leadership, which then can lead to further financial returns if you're able to license or export your technology elsewhere. So it's a huge opportunity, and wise policymakers are starting to invest in this and realize that if they can secure some of the companies and facilities in their districts, in their states, in their countries that have the cutting edge technology, this is how these products are going to be made in the decades to come. And so the firms and the political jurisdictions where they're located will have this head start, this advantage in securing those jobs and the prosperity that comes with them. So I really see this as an opportunity, and again, one of the best things that government could possibly be putting its money towards.
That's great. I mean, the reality is that if it creates jobs, that's a good thing. So we should be celebrating that. And what are some of the common misunderstandings that people have about this transition to a carbon neutral industry?
Good question. I think there are two that come to mind, and I try to tackle them both in the book, Zero Carbon Industry. One is that industry is too complex for policymakers to understand or to enact policies around, because industry does make millions of different products using countless different production processes. And there's some worry, well, do I have to be an engineer who understands every type of engineering in order to make regulations or policies? And fortunately, the answer is no, because there are policy design principles that allow you to make effective policy that promotes industry, often technology-neutral policy that leaves the details of technology implementation to engineers at private firms, but sets the stage, basically creates the environment in which these firms are competing and determines what will be rewarded, including clean production here. And the book walks through technologies that can decarbonize all of the industrial sector and shows that they are understandable for you and me and listeners and policymakers. It's just that there hadn't been a real effort to compile that information and put it together in a way that would be compelling and understandable for people who don't already work in industry, say. The other big misconception is the one we sort of addressed before about jobs, the worry that this would be a choice between the economy versus clean production. And the fact that jobs are often linked to investment, especially investment in productive capital and workers, means that that isn't a problem. And there are further policies that policymakers can take to protect their domestic industries. One example is a carbon border adjustment. The European Union is implementing one now. It essentially means that products imported into the European Union, they look at how much greenhouse gas emissions occurred when those products were produced, so called the embedded emissions or embodied emissions in the products, and then they tax the products according to that to put them on a level playing field with domestic producers so that they don't lose market share to imports made in a dirtier way. Similarly, products exported from Europe to places with weaker or lack of carbon pricing will have their carbon fees refunded so they aren't at a disadvantage in export markets either. So policies like this can really protect the competitiveness of industry while still allowing for strong policy to promote industrial decarbonization.
Got it. And in your book, you talk about the synergy between technological innovation and policy reform. Could you elaborate on which of these pillars you consider the linchpin for achieving a zero carbon industry?
Well, of course, we need both. We need policy to encourage and finance and accelerate technological development. And then ultimately, the technologies are what deliver the emissions reductions. The technologies are what allow us to produce these things cleanly. So, and it's something of a cycle. As the technologies are more mature, different types of policies can come in and help them take the next step, whether that's low interest financing to help, get a commercial facility set up or whatnot. So I think if there is all of it is needed, but if there isn't linchpin, or let's just say the next thing that needs to happen, I think it's in the realm of policy, because a lot of the technology is there. We understand how to provide industrial heat via electricity. We understand a lot of these processes on a scientific and engineering level. We just need to commercialize them as industrial equipment. And that's more a need for a demand signal for that type of equipment. And that's where policy can come in. That's where policy can create that demand, whether it's green public procurement, so there's a buyer for clean steel, or direct financial support, or carbon pricing with a border adjustment. All of these things are maybe the next linchpin to help get those well-understood scientific principles into commercialized technologies.
Excellent. And, we have a lot of engineers that are listening in and watching, and they may be asking themselves, how can engineers tackle the concerns over the initial cost of shifting to green industrial practices? So
cost is important, and it's something that technology and policy both can help with. So engineers can help by driving down the cost of clean industrial technology. Already there are some technologies that can dramatically cut the costs of going clean. For instance, in industrial heating, industries use steam quite a bit to produce a lot of materials and products. And one way to produce that steam is with an industrial heat pump. It's a machine that moves heat from one place to another, like a refrigerator or air conditioner, and it can provide several times more useful heat than the amount of electricity that it consumes. And that seems impossible thermodynamically, but it's not, because it's not converting the electricity to heat. It's just using the electricity to move heat from one place to another. Another example would be thermal batteries, a technology that allows you to purchase electricity in hours of the day when it's cheapest, because there's an abundance on the grid or from a cheap off-grid wind and solar project, so that the industrial facility doesn't have to buy electricity when it's expensive. So engineering technologies like these can help to overcome that cost gap between electricity and fossil fuels, since per unit of energy, electricity does cost more than fossil fuels today. And then and they can take advantage of policies like some of the funding mechanisms I mentioned with the Inflation Reduction Act or similar financing in Europe to help overcome those initial cost hurdles and get the technology demonstrations and first commercial facilities stood up and deployed.
That's great. Practical things to apply. So thank you for that, Jeffrey. And as someone who's chartered the path for industrial decarbonization, what would you say is the next big thing for this sector?
The journey to zero carbon industry involves both nearer term and longer term measures, or low-hanging fruit and then further out things. And I would say I'll name three things that I think are some of the next steps, the low-hanging fruit, which would be the key next things to do on the path to industrial decarbonization. They're energy efficiency, material efficiency, and electrification of industrial heating. So energy efficiency is can be very straightforward, using less energy to produce these goods and materials. But it's often thought of in terms of the specific machines, like the efficiency of an industrial boiler or a furnace. And that can be improved, but it also happens at higher levels. The efficiency of an entire facility, which looks at how you're integrating different types of machines and waste heat recovery and process design, let's say in the chemicals industry, as you move from one process to the next that uses the outputs of the last process. And then even beyond the factory, you can improve energy efficiency through things like process design or supply chain management. So there's great opportunities there. Material efficiency is another step, especially relevant for civil, geotechnical engineers and structural work, because there are opportunities to use less material while making structures as good or better as ones that use material wastefully. One example is with concrete, where it's often poured in molds with sharp corners because they're made of wooden boards that are hammered together. But you can use curved molds, for example, curved fabric molds, and you can put voids in the concrete by using like pockets of air, like a little inflatable plastic balloon that you remove after pouring the concrete, so that you can put the concrete only where you actually need it for structural integrity. And that can improve the building's performance. But it can make it more pleasant to be in the building if it's an open, more airy feeling, and it makes the building lighter, so you don't necessarily need quite as strong support columns or foundation if the total mass of the building is less. That's often not similar is true with girders, let's say, metal girders and reinforcements inside buildings, where they'll try to limit the number of different diameters and sizes of girders on a construction site to avoid complexity. Or rebar within poured concrete. Often the rebar all has the same diameter, even if it's not actually needed at that diameter everywhere in the poured slab. So there are approaches, for instance, factories can assemble grids of rebar of varying diameters and roll it, and then deliver it to a construction site where it's unrolled as a big sheet, and then you pour concrete over it. And that allows for much more complex patterns of rebar reinforcement without needing to do it on site, which slows the construction process and adds the risk of error. The last thing I mentioned was industrial electrification, and I won't spend long on this because I already mentioned heat pumps and thermal batteries, which are two key technologies. There are more in the book, like electromagnetic induction or lasers, electric resistance heating, but all of these are well understood and very efficient ways to produce industrial heat.
Excellent. Well, before we take our break, Jeffrey, final piece of advice you'd like to offer geotechnical firms that are beginning their journey towards zero emissions? You already gave some, but what's another thing that they can consider?
I think, one interesting bit of advice is that ultimately the cost of cleaner materials does not have to be higher or much higher than the cost of traditionally produced dirty materials. And so this is often a tiny vanishing share of the cost of the final product we're building. So a building can sell for many millions of dollars, and that includes the costs of the land and labor and engineering services and whatnot. And the cost of switching, let's say, the steel reinforcements from dirty steel to clean steel may add a vanishingly small fraction of a tiny fraction of a percent to the cost of the building, something that may not even be noticed, especially given that real estate prices may fluctuate by quite a bit more than that every year. So, and it gives, and there are buyers who will appreciate this. For such a tiny, tiny cost increment, they can say that their building was built with zero carbon, hydrogen-based steel and whatnot. So similar for concrete, I mean. So I think there's opportunities here to pursue these technologies and procure these materials at very reasonable cost and price them into the output products, even when there is a cost increment, because ultimately the cost differential in the materials is so small compared to the output, to the final product price.
Excellent. Well, thank you so much. So with that, we're going to pause for a moment, and we're going to come back in just a minute and close this one out with Jeffrey in our Career Factor Safety In segment. Stick around. All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your actual career? Today, of course, we're speaking with Jeffrey Rissman of Energy Innovation Policy and Technology, LLC. Jeffrey, you've already had a very successful career. When you look back in your career, what's one thing you've implemented in your career to give yourself a factor of safety in your career?
It's a great question and an important thing to think about. I knew I wanted to work on a problem that was scientific and technical in nature, but the purpose would be to help society make the world a better place. And I tried to pick a grad school area that would leave open a number of pathways to achieving that goal. So with an environment, I got 2 master's degrees, the city planning degree, but also the environmental engineering and science degree, so that if city planning didn't work out, then I would still have routes that I could go as an engineer or a scientist, or in this case, a science and policy person that could be rewarding and achieve my goals. And indeed, when I graduated, it was from grad school, it was in the midst of the Great Recession, which was a housing crisis and plunging property values. And ultimately, city planning is done at local government levels, and local governments are funded by property taxes predominantly. So they were not hiring amidst this housing crisis. So it was it would have been very difficult to get a role as a city planner. But fortunately, I had enough of a margin of safety to pivot and find this role, helping to start this new firm to provide technical and policy advice on achieving decarbonization and clean energy. Similarly, with I think throughout the career, I've thought about, where is it that something is needed? Where is there a gap here? the computer model I mentioned, the energy policy simulator, and especially my book, Zero Carbon Industry, were meant to fill gaps where there was a lack of information. And that helps open up additional opportunities career-wise.
I love it. I love it. You see a need and you see a gap of information, you find a way to fill it. Jeffrey, I really appreciate you coming on the show and sharing all the great insights with us. You shared really great information that's going to be helpful for our listeners and those that are watching. If someone wants to get more information, if somebody's trying to reach out to you, what's the best way for them to find you? And also information on your book. If you want to let us know where we can find it, tell us now, and then we'll also make sure we get that included in the show notes. So please let us know.
Sure thing. So the best place to go for more information, to learn more, is zerocarbonindustry.com. So that's the book's website. You can learn more about the book and all the chapters and data it contains, 48 data-driven graphics and more, as well as a 20% off discount code for your listeners. So again, that's zerocarbonindustry.com. And as far as email, you can go to the same place and sign up for the industry program mailing list. So that's the best way to be in touch by email, where we'll announce new research products that are coming out. So there's a link to that on zerocarbonindustry.com. And then if you want to learn more beyond the specific industry program, Energy Innovation, my company, my employer, you can reach them at energyinnovation.org.
Excellent. Thank you so much. This is a lot of fun. Appreciate you.
Thank you, Jared.
I hope you enjoyed our episode for today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all of your geotechnical engineering endeavors. Peace.